Debugging multi-threaded code bases is hard, and GDB doesn't offer much help. So today, I'm going to show you a completely new way to debug that will blow your mind. Time Travel Debugging. Program is really reverse executing here. All global variables and state variables are unwinding, not just the stack frames. So just press the last change button here, enter the variable that you want to see which changed its value last. Press the last change. And yes, we can see that at line 46, the G value was indeed changed. Debugging multi-threaded code bases is hard, and GDB doesn't offer much help. So today, I'm going to show you a completely new way to debug that will blow your mind. Time Travel Debugging is the perfect solution for debugging multi-threading issues. It makes debugging so much easier. Let me show you how it works. So here we have picked a small multi-threaded example that asserts in crash once we run it. And today we'll debug it in the Visual Code IDE. So first, open the file that you want to debug. In my case, it is race.cpp, and go to View and press the Run button. A small window will pop up in which you have to select UDB build and launch active file and press this green triangle here. If this window doesn't pop up, that means your extension is not installed. So go to View Extension and install the Time Travel Debug for cc++ extension here. Once done, you can now run your code. Press this green button and we can see that the program has built and now it will execute. All the debug windows have already come up, like all the variables can be seen here, then the watch, the call stack, the breakpoints that we set, and the timeline. So yeah, the program has started. Now just continue the execution of thread by pressing this continue button. Yep, now we can see that the program has crashed here. And there are 7 more stack frames before we actually reach to our point in the code. So we have to press the reverse finish or reverse step out button to actually reach that point. So now you must be thinking that we can just double click here on this stack and go to that particular stack frame. But no, program is really reverse executing here. All global variables and state variables are unwinding, not just the stack frames. Isn't it amazing? So just press it a few times to reach that point in the code. Yeah. So now you can hover the mouse over the variables to see their value, or you can add a watch here as well. So let me add a watch for G value. And we can see that the G value is 7. And 4 times 8 and 1. Old value is 7. 3 times 8, 7, 5. And A is 5. So obviously, they do not add up. A quick look at the function and we can see at the line above it, we are actually incrementing the G value by adding A here. And just 2 lines above, we are initializing the old value for G value. So something has happened between these 2-3 lines that has actually changed the G value. So we can see that the function is under mutex. So a thread which is in thread function 1 cannot change the G value. So something else is at work here. Let me bookmark this point as assert fail. The bookmarks can be seen here in the prompt as well, also in the timeline. So let's go backwards by pressing the reverse next or the reverse step over button to actually see where the value last changed. So if I press it, we can see that here the value is still wrong. So this is not the point. We press it one more time. And yes, here we can see that the G value was indeed same as old value. So something has happened between these two lines that has changed it. So let's bookmark this point as well by saying red correct value. You can even go to any of the bookmarks by pressing the go to bookmark button. Now guys, I'm going to show you the killer feature of UDB that will show you how easy debugging with UDB is. So just press the last change button here, enter the variable that you want to see which changed its value last, press the last change. And yes, we can see that at line 46, the G value was indeed changed, but this is not the point where we want to reach. So we press the last change again. And yes, here the value was indeed 78875, but it was incremented by 1 and change to 76. And a quick look at the function shows us that the function is not under mutex. So that's why the thread which is in thread function 2 has unsafely incremented the G value. Let's bookmark this point as unsafe increment. There is info timeline. We can also do info timeline here to actually see the point where the execution happened. So it shows the correct value, correct sequence of events. Like first the value was read, then it did the unsafe increment, and then the assert happened. So guys, a very simple solution here is to move this thread function to under mutex so that it waits for the log to be released to actually update the G value. So isn't it easy? So now you can stop wasting your time trying hard to piece the clues together by several logs over several days, or waste your time on slow and tedious forward-working debugger like GDB. Instead, you can just trace your data backwards from failure to root cause in just one debug cycle. So we have chosen this small example here to demonstrate the principle at work, but in real world, undo is used to solve issues in software using up to terabytes of virtual memory with many threads and running over several days. If you would like to see more expert debugging video content like this one, make sure you subscribe to our channel. One last thing. To make it easier to reproduce race condition, undo comes with a unique capability called thread fuzzing. This feature shakes the regular scheduling of thread in order to increase the frequency of concurrency bugs. If you're not familiar with how thread fuzzing works, take a look at the link in the description box below. Reach out and let us know what you think.